Hello students, welcome back to the IMS GATE Academy. Let's continue the foundation course on computer organization architecture. So today's session I will be continuing the instruction pipelining, that is a part 2. The last session we have started the instruction pipelining, right? So in which I discussed the basic things like how pipeline will work. So what are the stages are there, what is the speed of factor, how to get the speed of factor, efficiency of the pipeline, and also some of the numerical problems we have solved. So let's continue the session, all of you. So like this we have understand, this is part 2. In the part 1 we have seen what is instruction pipeline, the objective of the instruction pipeline, which I explained very clearly. Please go and watch the last session. Now the various stages occur in the instruction pipeline, like 2 stages, 4 stages, 6 stages, 5 stages. So there are the different stages which will be there, followed by we have seen the cycle time of the pipeline, followed we have seen the speed of factor, how to get the speed of factor of the pipeline. This is the speed of factor is a factor which is measuring the performance of the instruction pipeline, and also we have seen the efficiency. So followed by some numerical problems we have seen, like the question number 1, question number 2, question number 3, 4, question number 5, till question number 5 we have solved. So let's look into another question which was asked in GATE 2011 for 2 marks. So another question we'll see now, the question number 6, which was from 2011 paper. What the question is asking, see, consider an instruction pipeline with the 4 stages S1, S2, S3, S4, each with a combinational circuit only. The pipeline registers are required between each stage and end of the last stage also. So delays for the stages and for the pipeline registers are given in the figure. You see, the delay of a stage 1 is a 5 nanosecond. So delay of S2 is 6 nanosecond, this 11 nanosecond, this 8 nanosecond. And so these are what latch, right? Latch or register, latch or register. So this delay is given 1 nanosecond. Okay. So this is a basic thing which we already observed in the last class, like the type of pipeline which I discussed, the synchronous and asynchronous, linear and non-linear. This comes on the linear pipeline, which is synchronous nature. So they given the stages and their delays also, registered delay they given. So let's see what they are asking. What is the approximate speed of the pipeline in the steady state under the ideal condition when compared to the corresponding non-pipeline implementation? Okay. So they are asking that what is speed of factor? They are asking speed of factor. The last class we have seen the speed of factor. The speed of factor is what? The comparison with the non-pipeline, like how much it is, how much factor is better than the non-pipeline approach, we calculated also. Now in this case they said, no, what is the approximate speed up of the pipeline, the steady state under the ideal condition when compared to the corresponding non-pipeline implementation. Under ideal condition, please understand, and under ideal condition, the speed of factor means average, average time required for one instruction in non-pipeline approach. So non-pipeline approach by the average time taken for the pipeline for one instruction, okay. So if I say pipeline is ideal means, please, clock per instruction equal to 1. The last session also which I discussed, average clock per instruction in case of pipeline will be 1 is the ideal condition, right? Generally, so generally clocks will vary, time will vary, stages, but ideal cases it will be 1 clock. So now in case of non-pipeline will be the stages, number of stages will be taking one instruction, that is k by k clocks. So k clocks by 1 clock, k clocks by 1 clock, that we know. Okay, what is the k? K is a number of stages in the how many stages are there here? 4 stages. But it is not going to be answer like 4 by 1 more. Please understand, because the clocks I mentioned here, k clocks by 1 clock, but clock time, you see the cycle time in the pipeline, So now see, the stages delays are different here. They given a stages, their delays are different. You see first one taking 5 nanosecond, second 6 nanosecond, 11 nanosecond, 8 nanosecond they take it, right. Now see cycle time of the pipeline, non-pipeline, how to find? Cycle time means, please understand, the clock time only. So in case of non-pipeline, summation of all the stages. So simply marking summation I equal to 1 n stages. So like the stage delay sum divided by So 1 clock. So clock period, how to get the clock period? Maximum, so maximum stage, ith stage delay plus buffer overhead. So register value. Sum of this value, how much sum of this value? 5 plus 6, 11, 11 plus 11, 22, 22 plus 8. So 30 nanoseconds. So this is 30 nanoseconds divided by 30 nanoseconds divided by, yes, 30 nanoseconds divided by, so what value? 30 nanoseconds divided by, so maximum stage delay. What is maximum stage delay here? The maximum stage is 11 nanosecond. The register overhead, how much they given? 1 nanosecond. So 11 plus 1 is 12 nanoseconds. So this gives how much? 30 by 12 nanosecond. This giving how much? So this value gives 2.5. So 2.5 means option B is the right answer. Hello Saurabh Reddy. So very good afternoon. Very good afternoon. So let's continue the session like you are there in the last class also. Just continue the same little problem solving and we'll move on to other topics from the instruction pipeline. The basics we have seen in the last class. So you once again see the question. This question was asked in GATE 2011 paper. They given 4 stages. Thus each stage delay differently they mention and buffers also mentioned in between. They are asking the speed of factor comparison to non-pipeline. So what line they mention here? Under steady state, under the ideal condition, means ideal condition we know, right? Ideal condition means what? Clock per instruction in the pipeline will be 1 or not. That is what you know. Speed of factor is k, which we discussed. Yes or no? The last class we said speed of factor in ideal case will be what? K stages. So how it comes? K by, so k clocks required in case of non-pipeline. Pipeline case 1 clock required, but time of the pipeline we need to find out the spun cycle time. So cycle time for a non-pipeline case summation for pipeline will be maximum stage delay plus buffer overhead. So 30 nanosecond by 12 nanosecond, that gives the, so 2.5 is the speed of factor. Yeah. So any doubt in this case? So do you have any doubt? So we'll see one more question. We'll see one more question. Question number 7. Consider 4-stage pipeline processor. The number of cycles needed by the 4 instruction I1, I2, I3, I4 in a stage 1, S1, S2, S3 are shown below. Yeah, see the stage 1, stage 2, stage 3, stage 4, then I1, I2, I3. You see now. So stage 1 required, sorry, I1 instruction required 2 clocks in a stage 2, stage 1. So I1 instruction required stage 2, how many clocks? 3 clocks. I1 required stage 3, 2 clocks required, 1 clock required. Similarly, I mentioned the various number of instructions, the various stages. So each instruction is taking the different number of clocks in each different stages. Now they are asking what is the number of cycles needed to execute the following loop. The loop is what? For I equal to 1 to 2, I1, I2, I3 means the loop is repeating 2 times. 1, I equal to 1, I equal to 2 times repeating. How many instructions executing? I1, I2, I3, I4, 4 instructions. Option A given, options given 16 clocks, 23 clocks, 28 and 30 clocks. Options are given. So that may not be visible. I am writing here. Option A given 16 clocks, option B given 23 clocks, option C given 28 clocks, option D giving 30 clocks. These are the options. What they are asking here? How many number of cycles required to execute this loop under this 4-stage instruction pipeline? Chalo, understand. Suppose if I ask you question, how many clocks required? How many number of clock cycles? So number of clock cycles required in case of non-pipeline. Yes, non-pipeline. Can you tell me? Non-pipeline. Non-pipeline case. So each instruction has to go all the way. Sum of the clocks only. 2 plus 3, 5 plus 2, 7 plus 1, 8. 8 clocks required for instruction 1. Instruction 2, 4 clocks required. Yes or no? Instruction 3, how many? 5, 7. So this is how much? 7, 8 clocks required. So this is 6, 7 clocks required. Yes or no? Yes or no, all of you? So now 8 plus 4 plus 8 plus 8 plus 4 plus 8 plus 7. the 16, 27 clock cycles required. So 27 clock cycles required in case of non-pipeline. But similarly, we need to find our first one, the second one. For one cycle, it is for one cycle. So right. So one cycle for I equal to 0, for I equal to 1 to 2. So it will take 1 to 2. So this 1 times 27. So 2 times 27 into 2. This is going to 54 clock cycles required. In case of non-pipeline, 54 clock cycles required. But if I go with a pipeline, number of clock cycles required pipeline. Can you tell me how many clock cycles required if I go with a pipeline? So need to draw the timing diagram. Yes or no? Need to draw the timing diagram. Look at this now. Look all of you. So instruction 1. So instruction 1. Observe clearly. Observe clearly. Instruction 1. Instruction 1, stage 1, how many clock cycles required? Instruction 1, stage 1 required 2 clock cycles. So S1 required how many clock cycles? 2. I am marking here. So clock number 1 and clock number 2. Yes or no? So stage 2 required how many clock cycles? Instruction 1, stage 2. The stage 2 required 3 clock cycles. 3 clock cycles. So I am marking now here. Observe clearly. 1 clock number 1. So clock number 2, clock number 3. Yes. So clock number 3, clock number 4, clock number 5. Yes or no? Now stage. So stage 3 required 2 clock cycles. Stage 3 required 2 clock cycles. 2 clocks. So clock number 6, clock number 7. So stage 4 required 1 clock cycle. Stage 4 required 1 clock. Stage 3 required 2 clocks. This is 8. Is it clear? Is it clear? At clock number 8, S4 will complete. You see, clock number 8. So like now 2 plus 3, 8 clocks required, right? 8 clocks required. This is the transaction which we go. Correct. Now we have to run what? Instruction 2. You have to run the instruction 2. Observe the instruction 2. Now see. So means please understand here, whenever instruction I1 complete the stage 1 work, when it is doing the stage 2 work, can I give the S1? S1 for the instruction 2 or not? S1 for the instruction 2 or not? Confirm me. Confirm me. Yes. When instruction 1, stage 1 work over, instruction 1 doing the stage 2 work. This stage is free. This hardware is free. We are giving for instruction 2. So now I2 required S1 work how much? 1 clock only, 1 clock cycles. So this will complete here only. Now can I give the stage 2 for I2? Can I give the at clock number 4? At clock number 4, can we give the stage 2 for I2? No. Reason? Stage 2 is busy with the previous work only. So now please understand, instruction 2 has to wait to get the free of the what S2. Like instruction 2 has to wait for the S2 to be available. S2 to be available. We call stall. It is stalled till what? Clock number 5. It is stalled till clock number 5. End of the clock number 5, S2 is free. So S2 can be used here. S2 can be used. How many clock cycle required? Again 1 clock cycle only required. Now S3 is busy. We cannot give the S3 for this instruction 2. This again stalled till end of the clock number 7. Now here S3 is going to be free. S3 going to be free. So I can give the S3. So S3 required 1 clock cycle. Now S4 also required 1 clock cycle. At clock number 9, instruction I2 will complete. Is it correct? Is it correct? Now look at another point now. Now see. So instruction 3. So now see, instruction 1, stage 1 work over, end of the 3rd clock only. At 4th clock, stage 1 is free only. So stage 1 I can give given to the instruction 3. So instruction 3, clock number S1 required 3 clock cycles required. So I can mark here 1. So this is 2, this is 3. So I can mark this till. So this is the S1 is using. Now by the time S2 also free, so I can give the S2 for the instruction 3. Yes or no? So S2 required I3 S2 required 2 clock cycles. 2 clock cycles. From year to year it can be used. Yes or no? From year to year you can use it. So this is using. Now here S3 is free, we can use S3. So S3 required how many for I3 instruction? I3 S3 required 2 clock cycles. 2 clocks. Clock number 1 and clock number 2. Yes or no? Clock number 10 it will complete. Clock number 10 will complete S3. Then S4. S4 how many clock cycles? Only 1 clock cycle. At 11. S4. The instruction 3 will be completing at clock number 11. Now, so we have to deploy which instruction? I4. You deploy here end of this one. So I4 required how many? How many I4 is required? So I4 requires stage 1 only, 1 clock cycles, 1 it will complete here. So S1 work will over. But S2 you cannot use it because this is already busy. 1 stall. S2 can be given here. So S2 required how many clock cycles? So S2 required 2 clock cycles. Here 2 clock cycles. 1, this is 2. So 2 clock cycles here. Yes. So S3 is free here now. S3 can be used here. So S3 requires 3 clock cycles. 3 clock cycles. So please understand 1, this is 1, this is 2, so this is 3. So 3 clock cycles, this is 11, this is 12, 13. Yes or no? So S3 is taking 3 clock cycles. Then S4. So S4 will be there. S4 will take now 14th clock. 14th clock. S4 will take 14th clock. So end of the 14th. Yes or no? End of the 14th, all the 4 instructions are completed. Is it clear? Is it correct? Yes. Server ready. Is it clear? Now, one cycle, please understand, when I equal to 1, 4 instructions we have executed. How many clock cycles has taken? 14 clock cycles taken. Correct? Now, repeat second cycle, then how many total clocks required? Is it 28? 14 plus 28? Yes. Is it correct that one 28 is? No. 28 may not be correct, please observe. 28 is not correct. Tell me then. So how many clock cycles required if I repeat the second cycle? So means you understand when instruction I1 fetching is over. So you have to please whenever instruction I1 fetching is over, then what to do? You have to fetch I1 again. I1 you have to fetch. Now see, I'll be deploying here. I'll mark taking this here. Now from now onwards, instruction 1 I will deploy again. So because I will repeat here. I1. Yes, you see now. Okay, now see. Observe now. So I1 I have to again schedule it. I1 you have to schedule it. I1 you have to schedule it. I1 required how many clock cycles now here? I1 required again 2 clock cycles, right? 2 clock cycles. 2 clocks. So 1. So this is 2. So S1 required 2 clock cycles. So can I do S2 here? No. S2 is no. This is S2 is still busy. Stall. S2 can be given here. S2 can be given here. So now to S2 how many clock cycles required? S2 required 3, then 2. 3 clock cycles. 1. This is 2. This is 3. So 3 clock cycle required. Now S3 anyway completed. S3 can be started here. S3 can be used here. S3 can be used. How many S3 required? How many S3 required? S3 required 2 clock cycles. So now see 2 clock cycles, right? 2 clocks. So this 1, this is 2. This I am using. At 15, the S4 required 1 clock cycle. S4 required 1 clock cycle. At 16 will complete. Yes or no? Now see. So then I2 have to schedule it. Whenever stage S1 over, then I can schedule I2. So instruction 2, instruction 2, instruction 2. Now see. So S1 work. S1 required how many? 1 clock cycle only. It will complete here. But S2 is busy till this one. How many clock cycle? 3 clock cycle. This is stalls on stalls. Right now S2 can be given. S2 taking only 1 clock cycles. Now till this S3 is free, busy only. Stall here is stall. Then S3 can be used 1 clock cycle. Then S4 can be used here 1 clock cycle here. So clock number 17. So S4 work will over for instruction 2. Then you have to schedule this one again, I3. I2 I'll select it. I'll schedule I2. So I2, S1 work over, I can schedule the S1. S1 I can give in. So instruction 3, instruction 3. Instruction 3, S1 require how many clock cycles? Instruction 3 require 3 clock cycles. 3. So 3 means what? 1, this is 2, this is 3. Please understand. So till this free, busy only. Now S2 we cannot give it because S2 is busy here only. So this will one stall. Now S2 can be given. S2 can be given. S2 required how many? 2 clocks. So 1, 2, 2 till this very here. S3 over, S3 can be used here. S3 also require 2 clock cycles. At 18, please understand this will use here. So S4 I can do it here. At 19th clock this will complete. Yes. So till this point is clear. Is it correct? Sir already, please respond. Till this is clear, right? Now I4 have to schedule. I4 I can schedule here only. Instruction I4. S1 work. I4 S1. I4 S1 required how many clock cycles? 1 clock cycle only, right? 1 clock only. 1 clock. 1, 2, 3, 1. 1 clock cycle. Then complete here. So can I use S2? No. S2 is busy only, right? So busy till this one. These are stalls only. Now S2 I can use it. S2. So S2 required how many? 2 clock cycles. This 1 and 2. 2 clocks it will uses. So I can use S3 now. So S3 taking how many clock cycles? 3 clock cycles. So this is 1, this is 2, this is 3. Right. Clock number 20, clock number 21. Right. Clock number 20, 21 now. S3. Yes. Yes or no? Is it correct? Confirm me please. This is correct or not? So I4 taking stage 1, 1 clock cycle. Stage 2 taking 2 clock cycles. Stage 3 taking 3 clock cycle, 1, 2, 3. So number is correct, right? 15, 16, 17, 18, 19, 20, 21. Then S4 takes how many clocks? So S4 takes how many clock cycles? S4 taking how many clock cycles? I4, 1 clock cycle at 22. Yes or no? At 22 it is completing or not? Yes. This is clear? Yeah. So now see, observe this one. So from you have started here, okay? Please copy properly, ma. Please copy. Till this. So now number of clock cycles. So number of clock cycles in this case, number of clock cycles. Cycles required how many? 22. 22 required with the pipeline. I hope this is correct. Yes, is it correct or not? So this question was asked in one of the GATE paper. This was asked in one of the GATE paper. So options, if you see 22 is not there, so this you modify. So this is a 22. Option B is the right answer. Option B is the right one. 22 clock cycles required. Getting all of you. Non-pipeline required 54. So pipeline required 22 clock cycles. Yes, is it clear? But this is no time taking, right? It is taking time or not? Through that timing diagram taking time, yes or no? but you have to write it. You have to draw this one. Please observe. You have to draw this one. You have to draw this timing diagram clearly. Then only you are able to answer the question. Yes. But can we get any short method to get this one? Yes, yes. So that we need to look. That we need to look here. Let's observe how easily can be done. How easily can be done. The alternate solution which we have, this is not a standard thing, but this is based on this observation. Observation on this timing diagram only shortcut method can be obtained. So that is minimizing our time. So please understand, if you observe this next 5 minutes, so that's giving I can say very good things to be minimize your time. Minimize your time. So not only this type of questions, even other problems also we can use that approach, so that we can save the time for calculating the number of clock cycles for given a program. Let's observe let's observe. So what I'm trying to say here, look at the table here, clearly observe the table. Okay, now through table only we'll get it. Through table only we'll get it. Okay. What is the table has given? This only, right? I1, I2, I3, I4, S1, S2, S3, S4. There are the different clocks required in a different stages. Thus we know, correct? Saurav, keep that notes in your front of you and try to answer me based on the timing diagram only. So this concept came, and it is kind of just addition only. It's kind of only addition, but meaning is there. What is the meaning? I'll tell you. So now look this, how to do it. This one, the table is given. They ask number of clock cycles required to in a pipeline. They ask what you can do simply. So now see, I am going the instruction I1. I1 will go all the stages or not? I1 will go all the stages or not? First stage 1 works, stage 2, stage 3, stage 4 it will go. Now 2 plus 3 how much value? Tell me, 2 plus 3 how much value? 2 plus 3 how much value? 5. 5 plus 2 how much value? 7. 7 plus 1 how much value? 8. Done. So I update the column. Similarly update the row. 2 plus 1 3. So 3 plus 3 is 6. 6 plus 1 7. Right. So updating row and column easy. Add the values. Add the values. Yes, just confirm me. Addition is clear. Update the row, update the column. Just adding the things only, like no. 2 plus 3. End of the third clock. End of the fifth clock. S2 work of I1 will complete. End of the 7th clock, I1 third stage work will complete. End of the 8th clock, 4th stage will work over. Correct or not? Now see, just add it, that's it. Now remaining cells need to be updated. What do? You take this corner, 5 maximum of this 2 value. What is the maximum of this 2 value? 5. 5 plus 1 how much? 5 plus 1 6. So take again maximum of this 2 value. What is the maximum of this one? 6. 6 plus 2 how much? 8. Take maximum of this value. 8. 8 plus 2 10. Right. Then so maximum of this 2. What is the value? Maximum of this 2. 7. 7 plus 1 8. So maximum of this 2. What is the maximum of this 2? 8. 8 plus 2 10. So maximum of this 2. What is the value maximum of this 2? 10. 10 plus 3 13. Then maximum of this 2. What is the value? Maximum of this 2? 8. 8 plus 1 9. Then take the maximum of this 2 value. 10. 10 plus 1 11. Take again maximum of this 2 value. What is 13? 13 plus 1 14. Yes. First cycle got it. First cycle answer is clear. 14 only we got. Say yes or no? Yes, we got 14 cycle, right? 14. Yes. So how can you do for second cycle, sir? That is important. Yes, that is important. First of all, first thing you got it or not? First cycle you got, right? How to do? Simply add the row, add the column, add the row. Just then remaining cells need to be updated maximum of these two numbers. Then let me explain you the reason behind. What is the meaning of this one? What we did? The reason we will understand. Then I will work for the second cycle. That is also easy. So, sir, how I observe, sir, how you got 14 only here? How you got? How you did this maximum? How the concept? What the concept behind this one? Observe. So, what I am trying to do, stage 1, instruction 1. If you go and see the timing diagram, instruction 1 has to go all the stages only. That's what 2 clock stage 1 taking. 2 plus 3, 5, 5 plus 2, 5 plus 2, 7, 7 plus 1, 8. So, instruction 1 going sequentially only, right? All the stages into go. Even I2 also go all the stages only. Observe the things here. Now see, if I look at this stage 1 work here. I1 after using the stage 1 only, then I can use the stage 1 for I2 or not. Whenever usage of stage 1 for instruction over, then only stage 1 can given for the another instruction. So when stage 1 work is going on, end of the second clock. After that I can given for I2. That's what 2 plus 1, 3. End of the third clock, instruction I2 stage 1 work over. You can go and see, check it. Instruction 2 completing the stage 1 work, end of the third clock. After this work only I can give the stage 1 for I3. It is taking 3 clocks. That's what 3 plus 3 is 6. End of the 6th clock, instruction I3 completed stage 1 work. Then we can give on for a stage 4, sorry, I4 taking 1 clock. End of the 7th clock, you see 7 stage 1 work completed of I4. Yes or no? Yes or no? You go and see. You go and see here. See, I4th instruction, stage 1 work over, end of the 7th clock or not, you see? Sorry. Yes or no? End of the 7th clock over or not? So, that is the meaning you understand now. Now, row updation over, column updation over, then how you taking, sir, maximum? So, there are two things you need to understand. Whenever any stage you want to give to for an instruction, any stage if you want to allocate for any instruction, so that instruction should be free from the previous stage work, and this stage should be free from the previous instruction work. Did you understand my statement? Saurav Reddy, did you understand my statement? Whenever this particular stage you want to allocate for a particular instruction, so whenever the particular stage you want to allocate for particular instruction, this stage should be free from the previous instruction. Now this instruction should be free from the previous instruction. Whichever complete last, after that only that instruction or stage need to be allocated. So now see here how I taken a maximum point here. For instruction I2, I want to give a stage 2. For instruction I2, I want to give a stage 2. When I can give a stage 2, the stage 2 should be complete the previous instruction. I1 work should over. When I1 work over, at 5th clock over. Now I2 saying that I am at 3rd clock I am ready. You see, I2 saying that I2 completed previous stage work at 3rd clock only. At 3rd clock my work over. I need a stage 2 work. But if you want to give a stage 2 work, but stage 2 should be free, right? Then only we can give it. Are you getting my point, all of you? I do requesting, at the end of the 3rd clock, my work over, stage 1 work over, I need a stage 2. But stage 2 is not free. The stage 2 is free at end of the 5th clock. Because 5th clock only completing the stage 2 previous instruction work. That's the reason you see, I have taken a maximum of this one. So I said 2 points. What are the 2 points? Any stage if you want to allocate for any instruction, the stage should be free from the previous instruction. That instruction should be free from the previous stage work. This need to understand. Great, that is important line you need to understand now. So similarly you see now, I3 I want to give for I3, for instruction I3 I want to give the stage 2 here. Stage 2 I want to give for I3. It is saying that end of the 6th clock I am ready, I can take the stage 2. Now stage 2 is saying that yes, previous instruction work over, at the end of the clock I can give you. So both are happen simultaneously same time, so I can give it. That's what maximum 6, 66 only. 6 plus 2, 8. Now look at the here also seen. Instruction I4 required the stage to work. It is ready at 7th o'clock only. But at 7th o'clock, the stage 2 is not free. It is busy with the previous instruction work. That's why I have taken a maximum of this one. So that now maximum of this one 8, 8 plus 2, 10. So I hope you understand the meaning. So same concept I applied for the other cells. So we got the maximum 17. Is it clear? Now similarly we have to repeat for the second cycle. For the repetition. Whenever instruction I4 fetching over, we deployed I1, right? You see, go and see. Whenever instruction I1 you see, instruction I1, fetching is over, the fetch stage I given to S1 or not? Instruction I4 fetching is over, the stage I given for I1. That is a clue for me. So when we given end of the 7th o'clock, after 7th o'clock only we given. So from this point only you have to observe. So from this point you have to observe. Now see, 7th is input for me. 7, after 7 only I can give again stage 1 to whom? I1. I hope you understand my point. After 7 only I can give a stage 1 for I1. If I given how many clocks taken, this is one 2. So 7 plus 2, 9. So at 9 you complete. You see now, go and see instruction I1 completed its work is end of the what? You see now, 9th or not? 9th completed? Yes. So 9th is completed. We got now. So this is a clue for me now. So now see, I1 second stage can go. I1 you have to use second stage, but how to use the second stage here? How to use the second stage? Can I give second stage directly I1? No. I have to check for the previous instruction. Before I1 what was executing? My I4 was executing. When I4 has completed at 9, at 10 it is 10 is completing. I cannot add 9 plus 3 is at 11, 12 here. So my point, please understand, only one line please, it's not any big thing, like very small thing. So now for me whenever I1 again repeating, I have to look for the previous instruction. What is previous instruction? I4. So now see, stage 2 I want to give for I1. But I cannot give directly, but I have to check the previous instruction I4 completed or not. It completed at 10. So after 10 only I can give 10 plus 3. So after 10, 3 you can add it. So 10 plus 3, 13. You cannot add 13 plus 2 here. Reason I have to check for that one. So S3 I want to give for I1. S3 when it is completing at 13. It is also ready at 13 only. So I can give. So 13 plus 2, 15 I can say. So now see, S4 I want to give it for I1. So S4 should be free from the previous instruction. What is the previous instruction? I4. 14. This is 15. So now he's saying that it is ready at 14, but it is completed at 14 only. He's saying that I'm 15. I'm ready at 15, but before it is completed. So 15 plus 1 I have to take 16. So now second cycle what you have to do? So little you have to observe for column updation. Why column updation, sir? Because simply you cannot add it as for the what you did for first cycle. Second, thoda we observe for the what was my previous instruction is completing. So that I did. So now that 7 plus 2, 9 that I did. So 9 plus 3 I cannot take it, but I have to take stage 2 when it is completing from previous instruction. So 10. So that maximum of this 2 you understand. 9 maximum of 9 comma 10. Maximum of 13 comma 13. Maximum of 15 comma 14. So now this we have to observe. So you updated row column, right? Row is easy now. Row is easy. How row is easy, sir? So when I can go give S2 stage 1 for I2 after I1 only, right? Yes or no? Please confirm me. When we can give the S1 stage to I2? When we can give? After completion I1 work only. So simply you can add it. 9 plus 1, 10. 9 plus 1, 10. So 10 plus 3, 13. So 13 plus 1, 14. That's it, over. Now row and column updated. Clear? Confirm me, just confirm me so that I can forward. Just confirm me. This is clear. This is clear. Chalo. Now what to do? What to do? Row update. Sorry, remaining cells update. What to do? Simple. Maximum of this 2. So maximum of this 2 how much? Maximum of this 2. 13. 13 comma 1. 14. I am marking. Maximum of this 2. 14 plus 2. 16. So 16 maximum of this 2. 18. Right. Now similarly. So maximum of this 2, 15 plus 1, 16. So maximum of this 2, that is 16 plus 2, 18. So maximum of this 2, this how much? 18 plus 20 plus 3, 21. Yes or no? Now this maximum of this 16 comma 16 is 16 comma 16, 16, 16 plus 1, 17. Maximum of 17 comma 18 is what? 18, 18 plus 1, 19. So maximum of 19 comma 21 is 21, 21 plus 1, 22. Yes, done. Got the answer? 22, you got the answer or not? So it is taking more time, or timing diagram is taking more time? Yes. Yes. See, very simple, I am just concluding. What is simple thing I am concluding? First cycle very easy. Update the column, update the row. How? Just adding the number, adding the cells only. Update the column, update the row. First cycle. Remaining maximum only take. That is first cycle is very easy. Whenever first cycle only just given the table form, they ask number of clock cycles required to get this answer. Simply within a less than a minute you can get the answer. If they are given two loops cases, just we need to be little careful. What is the careful? Who has completed last instruction? Who is still working? Because whenever second cycle you start, second cycle I1 when you start, I4 is not completed, right? Just we need to take care of the I4. When I4 is completing, 7. So 7 se shuru karna. 7 plus 2, 9. So should I add 9 plus 3? No, because the stage 2 should be free from what? Previous instruction work, that I4. So this state information you need to capture. So maximum of this line we have to choose. So once you update the column, row updation becomes very easy. What is the row? Because I2, for I2 you want to give S1. When we can give very simple, after I1 completion only, it is come 9, 9 plus 1, 10, 10 plus 3, 13, 13 plus 1, 14. That's simple. Row and column updation becomes very easy now. So remaining things will be maximum of the cells only. Clear? Yes? Yes or already? Is it useful? Shortcut method is useful or not? Confirm me, ma? Confirm me? Okay, chalo. So now the basic problems which we the basic concept we have seen, implementation of the instruction pipeline, getting the speed of factor, efficiency and throughput calculation. Some problems we have seen, and the problems also with different stage delays are there, how to calculate the number of clock cycles also, which we observe. So now few observations we can do yet. What is the observation? Please understand. One line you can write down. Performance of the instruction pipeline is affected by two reasons. One is uneven stage delays. Second one is the dependency. So dependency among the instructions. Please observe what I am trying to say here. Sir, one request, please do the third iteration also, please sir. Acha, you want third iteration? So third iteration becomes easy only, ma. What is third iteration? So now latest thing you have to take it, 14, 18, 21, 22. 14, 18, 21, 22. See, what I have to do? Again I1 I want to schedule, right? When I4 is second cycle, when I4 is completing at 14. So 14 plus 2 almost 16, right? 14 plus 2, 16. At 16th clock, please understand, at 16th clock, third iteration of I1 will complete. So now you cannot take 16 plus 3 is 19. You have to check for when this is completing, because Stage 2 I want to give for I1, stage 2 should be free from the previous instruction. What is the previous instruction? I4. So 18. So 18 plus 3 how much? 18. After 18 plus 3 how much? 18 plus 3 21. 21 I have to mark it. Meaning 16 comma this maximum 18, maximum of 16 comma 18 you have to take it 18. 18 plus 3 21. Then you see, now see, S3 I want to give for I1. So when I4 is free from the S3 state, 21 only, it is also ready at 21. So maximum this to 21, 21 plus 2 23. So 23 understand. So here it is completed 22, it is completed 23, 23 plus 1 24 you have to take it. Now this is column updation. Is it clear? Saurabh ready? Column updation is clear. If this third cycle column updation is clear, row is easy. What is the row? 16 plus 1, 16 plus 1, 17. 17 plus 3, 20. 20 plus 1, 21. 21. So column row updation becomes like this. Yes or no? Row is clear? Row is easy now. Row is easy, simple. I2 I want to give for S1 I want to give for I2. After I1 work only I can give. That's what 16 plus 1, 17. 17 plus 3, 20. 20 plus 1, 21. This is done. So you know row, you know column, that maximum only you can do it, right? Can you tell me what is the answer you can get third cycle? Because please, they won't ask 10 cycles like this. 10 cycles you cannot repeat, right? 10, they won't ask questions. See, ultimately they want test for like how you student able to draw the timing diagram. That's only. They don't want to consume our time. This also old paper they ask, but maximum we can get 1 cycle, 2 cycle. But suppose if they say 10 cycles repeated, means what you can do? More than 10 repeated, you just somewhere they give some key information saying that like you can double the clocks. First cycle 14, second cycle 14, 14 you can add it. So that can be a case like if they specify. But they won't kill us our time like drawing the timing diagram of 3 or 4 cycles. Clear? Yes. Can you tell me now what is the third cycle you will get? Third cycle. So maximum of this to 21 plus 22, 21, 22 plus 20, this is 23, 23 of what is all 21, 25. So there you get 25. Here is 23. So 25, how much you are getting? How much you are getting? Third cycle. Did you get the answer? Yes, you can confirm me. Okay, just move on to this point. What I was trying to say, the performance of the instruction pipeline is affected by two reasons. One is uneven stage delays. Uneven stage delays, nothing but different stage delays. If the stage delays are different, definitely it is impacting the what performance of the instruction pipeline. The speed of factor get affected. Now second is the dependency among the instructions also will reduce the performance of the instruction pipeline. There are two reasons will be there. Uneven stage delay, dependency among the instructions. So first one we have observed already. See, this is the case you understand uneven stage delay. Different stages are having different delays in each stages. So that's definitely because ideal pipeline what we observed, ideal pipeline takes so 1 clock cycle for in each stage, right? That's only we observe. Not only 1 clock, so you understand one instruction take 1 clock cycle only. So that the theoretical which we have proven, but practical case it may not happen because the stages delays are different. So when it is looking at the second point, like dependency among the instructions. See, generally in a programming, if you see, some instructions are depends on others. Some stages are different depends on others. Like so, this also will impact the what the speed of factor of the instruction pipeline now. So let's observe. So third point you observe here. So see, this is an important point we notice. Now one note point you can observe here. Note point means please understand, which we know. In the pipeline, clock per instruction average. So what we observe, one only? Yes or no? Clock per instruction in the average will be 1 or not, which we proven also, like no. That's what in ideal case speed of factor equal to k, which we obtain also, right? Yes or no? So that means it's taking only 1 clock for each instruction in the case of pipeline, right? So due to this dependency, please observe first point, this one. So due to this dependency, please observe this average clock per instruction, it will be more than this one. So this is going to be delta clocks happen. Generally it is a 1 clock. 1 clock, it can happen some more than 1 clock. So more than 1 clock happens. Please observe. So some delta will increase. What is the delta? Because of what I am trying to say, due to difference among the instructions, it cannot be 1 clock, it will be more than 1 clock. How much more than, sir? 1 plus delta. So what is delta, sir, here? What is delta? Delta I am talking. What is the rate of? So rate of dependency among the instructions, and due to this dependency, each instruction, dependent instruction, how many extra time, extra clock cycle is taking. So delta is simply I am writing stall frequency. So stall frequency. So stall frequency multiplication of the stall cycles. How many stalls are happened? How many stall cycles are happened? So what is the meaning of stall frequencies are here? Percentage of the dependency, please. So percentage of dependency in the instructions. How many? What rate of the instructions are dependent? Each dependent instruction, how many extra clocks is taking? That's what delta is giving. So that value plus this one giving the, what I can say, this is a clock per instruction average in case of there is a dependency in the instructions. Depends in the instructions. So again concluding, so clock per instruction average will be 1 only. So no dependency, please understand. So no dependency in the instructions. Okay. Sir, dependency means or what is the meaning of dependency? Simple thing. Second instruction, suppose there are 2 instructions are there. Second instruction depends on the first instruction. Otherwise, understand, second instruction taking the inputs, so which is produced by the instruction 1 only. But the results may not be available. So the second instruction need to wait until the results is available. So that will increase the number of clock cycles. No dependency, average clock per instruction is 1. If there is a dependency, average clock per instruction in the pipeline will be 1 plus delta clock cycles. 1 plus delta clock cycles more. I hope you understand. Delta is more. What is delta? What rate of the dependency is there? Each dependent instruction, how many extra clock cycle taking? Let's observe. Program is there. Suppose observe the program. So program has 80%. Please observe. 80% instructions are independent. So independent one, each one taking 1 clock cycles. 1 clock cycles. Please understand. Independent instructions taking 1 clock, because if I not write this point also, meaning will see 80% instruction independent assumption. So 20% of instructions are dependent one, please. Dependent. So dependent instructions. So this dependent instruction, each instruction extra 2 cycles taken assumption. 2 clocks are taken due to dependency, extra 2 clock cycles taken. Now, so clock per instruction average how much it will happen? Observe. Please observe, generally all independent instruction taking 1 clock cycle only. I said no dependency. So due to this 20% dependency, see, due to the 20% dependency, it is taking 2 extra clocks here. So now 20% dependent and each incurring 2 clock cycles. So this giving how much? So 1 plus 0.4 is, so 1.4. See, average clock per instruction 1 on no dependency. Due to dependency 0.4 increased or not. Now average instruction per average clock per instruction will be 1.4 became now. If no dependency, it is 1 only. Due to dependency 0.4 clocks are increased for each instruction. So this you have to understand 1 plus delta here. I hope this point is clear. I hope this point is clear. Yes, yes, all of you. Other way understand. So program has, what I said you, program has 80% instructions are independent, taking 1 clock cycle only. There are 20% instructions are supposed to take 1 clock bar, and due to dependency 2 clocks are extra taken. This is 2 stalls are happen extra. These are 2 stalls are happen extra. So this value how much? 0.8 plus 0.2 into 3. This value how much? 0.8 plus this 0.6. This giving 1.4 or not? So both the meanings, this meaning and this meaning same only. Confirm me? Yes or already? Both are name same or not? Both are same or not? Meaning of this is same or not? Yes, you write either this way or this way, simple. So but I am just writing one naturally one will take, but due to dependency delta is taking. What is delta means? If I ask what rate of dependency is there and each how much extra is incurring. So that's only you have to understand here. Okay, now what is the observation I am making? Uneven stage delays also impacting the performance of the pipeline, and dependency among the instructions also impacting the performance of the instruction pipeline. There are two observations we made. Is it clear? Sometime by using this also they will ask questions. Sometimes they say no. So there is 4-stage instruction pipeline is there. Average clock per instruction is 1, but due to dependency 20% instruction dependent and which are incurring 3 clock cycles. Now what is speed of factor achieved with this non-pipeline to pipeline approach? This type of questions also they can ask. So then we should in a position to answer it. How? In case of ideal pipeline, generally non-pipeline will take 8 clock cycles and pipeline will take 1 clock cycle only, but due to dependency 1 plus something it will take, 1 plus delta clocks will take. So k by 1 plus delta you have to do it. So that gives the speed of factor of the particular thing. Clear? So now see, so next thing we'll observe hazards in the pipeline. Hazards means a dependency only. Hazards means here meaning dependency only. What is a hazard? Please, any condition which causes the pipeline to stall, pipeline to wait for some time is called as a hazard. Please, the point is clear. Pipeline hazard means any condition that causes the pipeline to stall, wait for some time is a hazard, also known as dependency. Or I mentioned a pipeline hazard occurs when the pipeline has some portion of the pipeline must be stalled because conditions do not permit to continue the execution. Also known as we can say what you call bubble also, pipeline bubble also we can tell. Bubble means what? So creating the stall, we have to wait for something to happen. So this hazard or dependency we can say. So there are 3 types of dependency we have now. Please, there are 3 types hazards or dependency. We have a data hazard. So data hazards are data dependencies. I hope you are understanding. Data hazard or data dependency. Second one is a control hazard. Hazards are dependencies. Third one is structural. So structural hazard. Structural hazards are structural dependency. There are 3 types of hazards we have. Please observe. Just I would like to write one line. Arithmetic operations. So arithmetic operations, please understand. Arithmetic operations generally leads or causes the data dependency. Arithmetic operations may create the problem of data dependency or data hazards. Second one, branch type of instructions. So branch type of instruction may cause the control dependency. The third line, please understand. So limited availability of resource. So limited availability of resources. So resources may cause the structural dependency. I given a reason how data dependency problems occur due to arithmetic operations. Branch type of instruction may create in the control dependency. Limited available resources or stages to understand. The bus connection may create in the structural dependency also. We'll observe one by one. So now, let's now just little brief introduction I will give for a data dependency, and the full things we can discuss in the next session. Now look at the data dependency. How data dependency problems occur? I will give a line, but let us understand how this dependency occurs and which is how this is impacting in the performance of instruction pipeline, we can observe. Data dependency, look at the point what I mentioned. The value of the source operand is not available, please, is not available when it is needed. Suppose one instruction want to fetch some operand, so that is not available when it is required. So now this instruction need to be wait until the operand is available. The waiting or stalling is creating impact on the instruction pipeline. Other sense I mentioned, data dependencies are occur when the one instruction in the pipeline, waiting for the results, which is not yet computed by the previous instruction. Hence, so second instruction forcefully need to be wait until the operand is available. So this waiting increases time in the pipeline, so that will impact on the speed of factor. So let's do observation. Here. Let's take two instructions are there. Instruction I1, okay, add register R1, register R2, register R3. So RISC type. So I'm taking the RISC type, please. So RISC type processor I consider. Nomenclature of this instruction is register R2, R3, both are added. The results is storing in R1 register. So another instruction I2 is there, multiplication, register R4, register R1, so register R5 is there. Nomenclature is what? R1 multiplication of R5, the results you are storing in R4 register. These are the two instructions which you have. Assume these two instructions are executed in a 4-stage instruction pipeline. 4-stage instruction pipeline. 4 stages are fetch, decode, execute, store. Also assume each stage of the pipeline is taking 1 clock cycle. So let's execute it. Instruction 1. So instruction 1 I want to fetch. First fetch the instruction. What is the meaning of fetch instruction here? Addition. Add is opcode. Opcode we fetched. Fetch taking 1 clock cycle. Then you have to decode. Decode means, can you tell me what is the meaning of decode? Decode means identifying what type of instruction, whether it is addition or subtraction, what type of this instruction, determine the instruction. After determining, source operand need to be fetched. Observe, these two are the source operand, this is destination. These two are the source operand, this is destination. What are the source operands are there? R2, R3 need to be fetched at clock number 2. Then execute. What is execution? R2 plus R3 at clock number 3. Then you have to store it at clock number 4, register R1, storing in register R1. Is it clear? This will happen. Now whenever fetch of a instruction 1 over, it is doing the decode. Now fetch stage is free or not? The fetch stage is free, so simultaneously now fetch can be done here. Fetch simultaneously means when it is decoding, I am fetching now. At time 2, at clock number 2, fetch and decode both are working here. So I'll fetch multiplication here. Fetch. Then decode. What does the decode means? What I said decode means? Determine the instruction, fetch the source operand. What are the source operand required for the multiplication? R1, R5. Say sir, no, R1, R5 required. But can I decode the R1, R5 now? Do we have R1 now? R1 is available end of the 4th o'clock or not? Because R1 results is available end of the 4th o'clock. After storing only R1 is available. But I want to decode right now only. Clock number 3 only I want to decode, but that is available end of the clock number 4. What to do? So you have to, second instruction, have to wait until this available here. Then here I can decode. Na? At 5th clock, observe, decode means register R1 available, register R5 is available. Decode. Then after that I can execute it. What is execution? 6th o'clock? Execution R1 multiplication R5, store in register R4. 7th clock. See. Please observe now, clocks are increased or not? Yes or no? How many clocks are increased? 2 clocks increased. If there is no dependency, these 2 instructions would have completed at clock number 5th only. Second instruction would have been completed clock number 5th only, but it is completed now 7th clock. Reason, so now it is just waiting for the operand. This is not computed by the previous instruction. Previous instruction will be produce the result at the end of the 4th clock, but I needed clock number 3 only. So this is increasing the time, right? Pipeline time increase. So when pipeline time increase, speed of factor will reduce or not? Yes, speed of factor will reduce or not? This is the data dependency problem. Arithmetic operations are creating this problem or not? Arithmetic operations are creating this data dependency problems. I hope you understand the problem. Can you think about what can be done to minimize? What can be done to minimize the number of clock cycles to avoid the data dependency? If there is no data dependency among these 2 instructions, both instructions could have completed clock number, so till total 5 clocks only, but due to dependency increased. Now can you give us some suggestions and ideas to minimize the clocks here? How we can avoid the data dependency problems? So I'm just thinking for the solutions. We need to think for the solution. Problem is clear? First of all, identify the problem is clear or not. Identify means the how problem occurred we have observed or not. Yes. Yes. Saurav ready. So now we need to look into solutions. We need to look into solution. Do you have any idea? So do you think any what can be done to minimize the number of clock cycles? Yeah. So I'm just asking for solution part. Solutions. Yes. What can be done now? Minimize this thing. So there are two types of solutions. Okay. One is software solutions. Software solutions. The second one is a hardware solution. So what I was taking, so when I discussed initially, we were talking the pipeline is giving more performance compared to non-pipeline approach. Like if I take 5-stage instruction, pipeline will produce the optimally 5 is a factor, speed of factor we can achieve. But practically, if you see, these are the challenges we are facing or not. Yes or no? When I increase the number of stages, speed of factor also will increase. This was observation previously we discussed. Yes or no? When you increase the number of stages in the pipeline, speed of factor also going to be increased, that we observed. But practical case, if you observe, the managing the pipeline is going to be a complex. See, there would be a lot of dependency among the instructions, even other reasons which will impact in the instruction pipelining, right? Performance instruction pipeline or not. The software solution are compile based solution, like compiler based solutions. So compiler based solution is there. Hardware solution, there are two hardware solutions are there. One is simply installation of stalls. Installation of stalls. Second is the operand forwarding. Operand forwarding. So this compiler based solution also we can say instruction rescheduling. If I do the rescheduling of instructions, that can be avoid the data dependency problem, but little complex overhead, and we can also look into the hardware solutions, so that installation of the stalls and operand forwarding. Clear? So there are 3 approaches we have for dealing with data dependency problems. We will discuss one by one each, then we will conclude which one is a better among 3 that can be given a conclusion. So let me continue this session into the tomorrow session, that is 17th May. So tomorrow also at 6 p.m. we have tomorrow we have a classes at 6 p.m. I'll be discussing, and apart from this, so we have another schedules also. So tomorrow going to be start the theory of computations. See, May 17, 23, 24, like the complete schedule is there. The topic which the faculty is going to discuss on theory of computation. This is taken by another faculty, Amit sir. So you'll be starting tomorrow at 4 p.m. From tomorrow onwards, like every week two sessions will be there. So that's the TOC also going to be discussed. Now similarly, and once computer organization topics over, I'll be starting even operating system also. Very soon I'll be sharing the schedule for that operating system. I will try to cover the most of the important topic from OS also. Fine, Saurabh. And also you kindly intimate to your students, your friends also, like you just pass the link so that they can also join. So now operating system yet to be start. I'll start once COA the major portion over. I'll start the OS also. Yes, Saurabh. So share the link to your friends, so though they also get benefited out of it. Yes. So this is a complete schedule going to happen for, sorry. So till you see June. So June 8th, in parallel to this also, parallel to this operating system will go. Like it can happen like 2 days TOC, 2 days operating system. Like once if I done this, the CO part. Clear? Chalo ma. Okay, we'll meet. So next session, that is the 17th May. So then I'll continue. Try to join the session compulsory, because now you have to understand the data dependency problems. We'll see the solutions. We also deal with the control dependency. We'll also couple of problems, sufficient problems on each topic we'll observe, so that you will be in a complete understanding on this topic. Which topic? Pipeline topic will be covering. The weightage will be 2 to 3 marks we can expect from the GATE exam. Fine. Okay, I'll be stopping the session. Thank you so much.